right? This is example 8. It says this data represents the total amount in billions of dollars that's spent on healthcare in the United States between 1970 and 1996, where t equals 0 is 1970. So you could see our t values go from 0 to 26. So that's 1970 to 1996. Find a model for the data, which means you would have to enter it all and then do the stat plot, look at it, see what the shape looks like. Now, I've already entered it here. Right? I've already got all the data in there. So I'm going to turn on the plotting of points so I can see what it looks like. Second, 1, and turn on the plotting of points. And zoom 9 so that I can see it. And then I've got to just, go back to the original 6 models. Which one does that look like? Is it exponential decay? Is it exponential growth? Is it a logarithm? It's exponential growth. So you're going to use the exponential model for that. Right, so let's go to stat, arrow over to the calc, and then find the exponential. It's right there, 0. What?
Could you please put John on the exponential?
Sure.
Thank you.
Okay. So there, notice, here's the basic exponential. A times b to the x. And they've given you the constants a and b. So you fill it in. Right? So it should look like, at that point, it looks like this. Right? That's the screen that I just got. I filled in for the A and I filled in for the B. I put them all in, and then I looked at them. I said, I think exponential is correct. So then I did stat, calc, and I found the exponential in the list, and I came up with this information right there. Now, I could put it, let's go back to the calculator, and this time I'll just enter it in, just so if that's what you're going to end up doing, you can see. It would be 81.1 times 1.11. I think I actually did 1.112 hat x. And now if I look at the graph, you should see the line does go right through it, right? Around this? No, I mean, this is just showing a multiplication, right? You could use parentheses, or you could do just show a multiplication like that. It doesn't matter. But you could see that is the right, it looks like we've modeled the data that's there. Now, their question is going to be, the last part of the question is, use this model to estimate the amount that's spent in 2004. Well, what's the value of t in 2004? Since 1970 is t equals 0, 2004 is 34. So you would want to plug in 34 there and make your estimate. Or if you've already got it in the calculator, then again, you could just go to the table of values, scroll down to 34, or you could set it to ask, which for this calculator is easier, and just plug in 34 for x. And you can see that the spending is now 2996, and they said that was in billions. So 2996 means trillions. So that is a forecast at that point, that in 2004, according to this model, we expect to spend about $3 trillion on healthcare. Now, do we think that that's accurate? I could tell you that looking at that graph, go back to the graph, and it's doing something at the end there that looks like the model's starting to lose it, right? Right at the end there, it looks like the model's going up, but the data's not going up that fast at all. So you could imagine that that 3 trillion is coming from somewhere up there. This book was written in 2003, and at that point, this was actually a forecast. We can actually go back and see what actually the healthcare costs were. It looks like maybe they leveled off a little bit, or they just stopped going up quite that fast. So y of 34 equals, and we just said 2,996. So that is 2.996 trillion.